Okay, I'd like to demonstrate some Chapter 4 homework problems for you guys because these are a little bit tricky. The first one I want to look at is number 14. It says, Ruth is flying from Boston to Denver with a connection in Chicago. The probability her first flight leaves on time is 0.2. If the flight is on time, the probability that her luggage will make the connecting flight is 0.8. But if the flight is delayed, the probability that the luggage will make it is only 0.65. And it has two parts. When you see a problem like this with a bunch of conditional probabilities, what you want to do is draw a tree. It's really important to actually draw the tree. So the first thing we have here is that her flight is either on time or it's late. It says in the problem that it has a 0.2 probability of leaving on time. That means it must have a 0.8 probability of leaving late, because remember, the probability of an event is 1 minus the probability of its complement, or you can use your sort of common sense of things. It says if the flight is on time, the luggage will arrive, I'm putting OK for arrive, with a probability of 0.8. If it's late, the probability that the luggage arrives is only 0.65. I'm going to go ahead and fill in the rest of this tree. If she's on time, the probability that the luggage doesn't come must be 0.2. And if she's late, the probability that it doesn't show up must be 0.35. Once you've drawn your tree, you multiply along each branch to get the probability of the entire branch. So for instance, for here, when I go along this top branch, 0.2 times 0.8, well, that's exactly what I do. I multiply 0.2 times 0.8, and that gives me 0.16. What this is the probability the flight is on time and the luggage arrived. Okay, when I multiply along this branch, I'm going to get 0.04. When I go along the late luggage OK branch, I get 0.52. And when I go along the late luggage not OK branch, I get 0.28. Notice if I add these up, I should get 1. This should be all the things that can happen. Okay. Part A asks us whether those events are independent, and they are not. Why aren't they independent? Because the luggage is less likely to arrive on time. Or to arrive if the flight is late. Okay. And the second part is the fun part. It says probability that luggage arrives. So there's two paths here that the luggage can arrive, right? There's this yellow path and there's also this blue path. All I have to do to get the probability that it arrives at all is to add these up. I've got 0.16 up here and 0.52 down here. You can do it like this. It's the probability that the flight is on time and the luggage is okay, plus the probability that it's late and the luggage is okay. Those are disjoint, so we can just add them. That was 0.16 plus 0.52, which is 0.68. Okay, now I want to do this number 16. It says on any given day at some company, about 1% of the day shift employees and 3% of the night shift employees are overtired. Notice that's about a conditional probability. The second sentence says 60% of the employees work the day shift. What percentage of overtired employees are on the night shift? Okay, this is another tree diagram problem. I really like these, but many people do not. So let's start with the thing that's not conditional. That's this part. So on the day shift, we have 60%, 0.6. And on the night shift, we have the remainder, must be 40%. Okay, now it says 1% of the day shift employees are overtired. That must mean that 0.99 are okay. Of the night shift employees, 0.03 are overtired. That suggests that 0.97 of them are okay. Let me go ahead and multiply these paths out. Oops. Just like last time. Okay, so 0.01 times 0.6 is 0.006. That's the percentage that are, well, that's the proportion that are overtired and work the day shift. 0.99 times 0.6, that's 0.594. 0.03 times 0.4, that is 0.012. And 0.97 times 0.4, that's 0.388. We could check those add up to 1. I'm not going to check it. You have to trust me. Okay. It wants to know what percent of overtired employees are on the night shift. This question is the same as saying, what is the probability that I'm on the night shift given that I'm overtired? So remember, this little line means given. All right. For this, you always put the thing that's given on the bottom. It's the foundation of your problem. So all we know is that you're overtired. So we want to go the probability of overtired. And then on the top, we have both. The probability of night shift and overtired. Okay. The top part is easy. The night shift and overtired. That's what we did right here, and we got 0.12. That's these guys. So that's 0.012. Then for overtired, we have to add that one to the other way you can be overtired, which is to be on the day shift. And that was a 0.06. When you multiply this in your calculator, you're going to want to make sure to use a parenthesis on the second number. So I would type it like this, 0.012 divided by parenthesis 0.012 plus 0.06. Oh, sorry, that should be a 0.06. Okay, and that should give you, oh, let me do it, 0.012 divided by 0.012 plus 0.006. That gives me 0.667 approximately. And that's it.